Now I'm going to consider six possible cases. The first case is where the losses are IID. IID means independent and identically distributed, and the number of investments is fixed. The second is the same, but the number of investments is a random variable. The third is where the losses are INID, which means independent.
Sorry, we cannot see the screen.
Sorry. Yeah, okay, it's my fault. Can you see it now or no, not yet? Oh yeah, can you see it now?
Yeah, we can see it. Thanks.
It's upside down. It's always upside down. Okay, right. So these are the six cases. The first case is where the losses are IID and its number of investments is fixed. The second is where the same, but the number of investments is a random variable. The third is where the losses are INID, which means independent but not identically distributed, and the number of investments is fixed. The fourth is the same, but with the number of investments random variable. The fifth is where the losses are dependent random variables and the number of investments is fixed. And finally, case 6 is where the losses are dependent and the number of investments is a random variable. Right, so I'm going to consider these six cases, and for each case we are interested in these three variables. Obviously there are more, but in this chapter we will consider only these three variables. So S is the total portfolio loss, so it's the sum of the losses. U is the minimum portfolio loss, so the minimum of x1 to xn. And V is the maximum portfolio loss, so it's the maximum of x1 to xn, right? So case 1, there are a lot of formulas here, but you don't need to know the derivations. You only need to know how to apply the formulas. So I will do a lot of examples later on. So for example, in case 1, the formula for the CDF of total portfolio loss is given by this. And the formula for the PDF is given by this. I don't expect you to know the derivations of these formulas, although I have given the derivation. I mean, I have basically given the formula, but not the derivations, right? So I don't expect you to know the derivation. So this is an example. I hope you guys went through the videos I asked you to watch. So if you have any questions in advance, please let me know. All right, so this is the CDF of U. Remember, U is the minimum portfolio loss, and it turns out to be equal to this, right? Again, I don't expect you to know the derivation, although it is given here, right? And this is the PDF of U, right? And then this is the CDF of V. V is the maximum portfolio loss, and it's given by this formula, the CDF of V. And this is the PDF of V, right? And this is the second example. I hope you guys went through this. And if you have questions, once again, please feel free to ask me, right? If you had questions with this example or any other examples, right? This is more of that example. That's example 2. This is example 3, right? Example 3. Hello guys. This is more of example 3. All right, so that completes case 1, right? Case 2 is where, as I said before, case 2 is where the losses are IID, but the number of investments is a random variable and is independent of the losses, right? In this case, In this case, the CDF of S, the total portfolio loss, is given by this formula, and this is the PDF. Once again, I don't expect you to know how to derive these formulas, but you should know how to apply them if I give you a problem. Okay? So that's and the CDF of U, remember U is the minimum portfolio loss, is given by this formula. Again, I've given you the derivation, but I don't expect you to know. I don't expect you to know the proof, but if you can understand the proof, that's good. Right, and this is the PDF of U, right? And this is the CDF of V. V is the maximum portfolio loss, right? It's given by this formula, and this is the PDF of V, right? And I've done some examples. This is example number 4. I hope you guys went through this example, and let me know if you have questions. And this is example number 5. Yeah, let me know if you have questions. All right, so that completes case 2. Now the next case I want to consider is case number 3. Case number 3 is where the losses are INID, which means independent but not identically distributed, right? And the number of investments is fixed. In this case, it can be shown that the CDF of total portfolio loss is given by this formula. Again, I don't expect you to know the derivation, but you should know how to apply it if I give you a problem, right? Okay, and this is the density of the total portfolio loss, right? This is an example, right? And the CDF of U, remember U is the minimum portfolio loss, is given by this formula, right? Again, this is the derivation. I don't expect you to know the derivation, but if you can follow the derivation, that's good. And this is the PDF of U, right? And this is the CDF of V, right? V is the maximum portfolio loss, and it's given by this, right? And this is the PDF of V, which is given by this, right? Okay. Now some math. These are some. I'm sure you know this stuff. This is the product rule for differentiation. I'm sure you did this in your first year. So you have two functions, right? The product rule is this. When you have a product of 3 functions, this is the product rule. And when you have a product of n functions, this is the product rule, right? I'm sure you know this stuff from your math courses you've done before. This is example 7. I hope you followed this. Example 8. Example 9. I hope you followed this. There's more of example 9. Okay, now the next case I'm going to consider is case 4. Am I going too fast? I mean, you guys have questions or what? Maybe I'm going too fast. You okay, Robert? Any of you guys have questions? Hello guys, you okay?
Morning, sir.
Morning. Hey, Veronica, are you okay? Mohammed, are you okay?
Yeah.
All right. So the next case I'm going to consider is case number 4. Case number 4 is where the losses are INID and the number of investments is a random variable, right? So in this case, the CDF of S, the total portfolio loss, is given by this formula here. Again, I don't expect you to know the proof, but you should know how to apply this formula, right? And this is the PDF of S, right? And this is the CDF of U, which is the minimum portfolio loss, is given by this, right? And this is the PDF of U given by this. And finally, this is the CDF of V, the maximum portfolio loss given by this formula, and this is the PDF given by this formula. Right, guys, so that completes the 4 cases. So remember, I asked you guys to watch the videos for the case 1 to case 4, right? So I just went through the scan stuff for cases 1 to 4, right? You guys have questions or what? Some of you look lost. Did you guys watch the videos or what? Yeah. Okay. All right. So let me in the remaining time, what I'm going to do, as usual, is to do some examples, right? So, yes, sir. You have questions? Hello. So let's start with one example. Example 1. So the example is as follows. So suppose yes, find the, so you have a random sample from an exponential distribution with parameter A, right? And we want to find the CDF and the PDF of U and V. Remember, U represents the minimum portfolio loss and V represents the maximum portfolio loss. All right, so let's start with the U first of all. So the CDF of U is you can write it like this, okay? Now I'm going to write this like 1 minus the probability that capital U is greater than little u, right? And the reason I'm doing that, it will become clear in a minute why I'm doing this, right? So this will be 1 minus the probability that yeah. Remember, if the minimum of a sequence of random variables is greater than u, that it implies that each random variable in that sequence has to be greater than u, right? Yeah. Are you okay so far? Now, in the next step, I'm going to use the fact that x1 to xn are independent random variables. So you can write this as yeah. You okay? Right. In the next step, I'm going to write this as what this probability, you can write it as 1 minus the probability that x1 is less than or equal to u. And this probability, you can write it as 1 minus the probability that like this, okay? So this is like, now what you have here is the CDF of the x1. Now remember, for the exponential distribution, Do you guys remember the exponential distribution? What's the CDF? You don't remember? It's 1 minus e yeah. All right, so this becomes e of minus au, because the 1 and the 1 cancels. Okay. So this is this CDF of u, which is the minimum portfolio loss. Okay. Are you guys okay? Everybody okay? Everyone? All right. Now to find the PDF, of u, you just differentiate this with respect to u, right? So if you do that, you should differentiate this with respect to u. You got NA okay. All right, guys. So that completes the first part of example 1. Any questions so far? The second part is to find the. You should go back to this. Is to find the CDF and the PDF of V. Remember, V is the maximum portfolio loss, right? So let's see how we can do this. Can I take this away or not? I mean, you can copy it later on. I will scan everything. I mean, you can copy it later on. Okay. So, okay, the CDF of the CDF of V is this, yeah, which is the probability that the maximum of x1 to xn okay. Be with me, guys. Right. Now, if the maximum is less than or equal to V, then every element, every one of the random variables has to be less than or equal to V, right? So in the next step, I'm going to say this is yeah. All right. Now in the next step, I'm going to use the fact as independence. Okay. Because of independence, you can write this probability as this. Now, this is the CDF of x1 at V. Now, I told you before that this is 1 minus E minus A times V. Okay. Yeah. So this is this. Are you okay now? So this is the CDF of maximum portfolio loss. All right. Now the PDF of V is, you just differentiate this with respect to V, right? and if you do that, you will get if you differentiate this, you get n times a e minus a v. Okay, this is what you will get. Are you guys okay? Any questions? Those of you on Zoom, if you have any questions? Hello, guys. Yeah. All right, so that's example 1 finished, okay? Are you okay? The next example I'm going to do, can I take this away? You can copy it later, guys. I will scan this and put it online later today. Okay, here suppose okay, guys, so here this belongs to case 2, right? Remember we talked about the 6 different cases. So the example 1 which I just did belongs to case 1, and this example 2 belongs to case 2 because you have losses which are IID, but the number of investments is a random variable. In this case, it has a geometric distribution with parameter p. Okay, so let's see how we can do this. Okay, so first of all, let's try to find the CDF of U, which is the probability that capital U is less than U. Yeah. And this is the probability, you can write this as 1 minus the probability that capital U is greater than U. Yeah. And this you can write as 1 minus the probability that the minimum of x1 to xn is greater than U. Right, now here denote that capital N is a random variable. It's not a fixed number. Right, so in the next step what you need to do is the following. You need to You see what I have done. This is known as the total probability rule. I'm not sure whether you're familiar with this. I mean, you must know this from your first year probability. Total probability. Do you remember this or not? You probably did this in your first year probability 1 course. Okay. Hi. Now remember that we are assuming that n is a geometric random variable, right? Okay, so this guy is gonna be 1 minus the sum from 1 to infinity. Because we are conditioning on capital N equal to little n. Hello, you okay, ma'am? Some of you look lost. Are you okay? You sure? If you have questions, feel free to ask me. Okay, so this becomes you see, I'm removing this conditioning here because we are told that capital N is equal to little n. So we can replace capital N by little n here, right? That's what I have done. Now the probability that capital N equal to little n, because n is a geometric random variable, I'm sure you know this. Okay, this is the probability mass function of a geometric random variable, right? Okay. All right. So this becomes 1 minus the probability from, 1 minus the sum from 1 to infinity. This guy you can write as and this probability using independence, using the fact that these are independent, you can write it as okay. Now each of these we know from the previous example that this guy here is 1 minus e of minus au. Yeah, and we also know from the previous example that this guy is okay. Okay, so this becomes, are you guys with me or not? You sure? If you have questions, please let me know. Okay. Right. Yes. Okay. Now the next thing I'm going to do is the following. I'm going to write the n as n minus 1 plus 1 times au okay, and Right, and now I'm going to take the p outside of the summation, and also I'm going to take this guy here outside of the summation. So you get this to be equal to 1 minus e of au times p. Then in brackets you have yeah, you see what I've done. I've taken the last, there are three terms here. I've taken the last term outside of the summation, and also I've taken the p outside of the summation, so you end up with this. Yeah. Right, now in the next step I'm going to make the substitution that m equal to n minus 1. So set this substitution, and under this substitution this summation will become 1 minus okay, it becomes this. Right, now do you know about this you know, there's a formula which says that, you might have seen this before, I don't know. You should have something like this, yeah, and x is a number that is less than 1, then this is equal to 1 divided by 1 minus x. Do you remember this or no? You might remember, I don't know. So using this formula, right, you can simplify the summation as follows. Yeah? You guys okay? So if you like, you can simplify this further. You can take this up okay. Correct me if I'm wrong. So this is the CDF. This is the CDF of the minimum portfolio loss, right? And are you okay with this or no? Any questions, guys? Yeah, Robert, you okay? All right, now to find the PDF, so let me keep it here. To find the PDF of U, you need to differentiate this with respect to U, right? So you need to use the quotient rule. I'm sure you remember the quotient rule for differentiation, right? So Okay. So this is what you will get. I mean, obviously you'll need to simplify this. I think it can be simplified, but I don't really want to spend the time, but I'm sure you guys know better than me about how to simplify things. Okay? So I just leave it like that. So please try to simplify this expression. Okay? So so what I have done so far is the CDF and the PDF of the minimum portfolio loss. And similarly, you can derive the CDF of V all right, is this, and this will become the probability that okay, yeah, and in the next step I'm going to use the total probability rule, which I talked about earlier, right? So you can write this as the sum from 1 to infinity is from 1 to infinity because the geometric random variable is defined from 1 to infinity, right? So times the probability that right? So this is the, once again, this is the total probability rule. Okay. Now this becomes yeah, because I'm choosing capital N to be little n, and this is the probability of a geometric variable, which is p times 1 minus p power n minus 1. Okay. Now, if the maximum is less than or equal to v, then is this, yeah. Now, in the next step, I'm going to use independence. So, using the fact that x1 to xn are independent random variables, you can write this as the product yeah. Now each of these is the CDF of a geometric random variable, sorry, of a exponential random variable. So what you have is this guy here is 1 minus e minus a times v. Yeah. Okay, so this becomes this, right? Now I'm going to pull out a few things. I'm going to pull out this guy, and I'm going to pull out the P, right? So inside the summation, you will have this, yeah. All right, guys. Now using the same, sorry, I'm gonna set m equal to n minus 1. So if you do this setting, then the above will become right, it becomes like this, yeah. Now in the next step, I'm going to use the summation formula that I gave you earlier. So this guy will become 1 minus times 1 minus 1 over 1 minus this is what you get. So this is the CDF of the maximum portfolio loss. Are you guys okay, or are you lost? Hello guys, talk to me. Are you guys okay? You okay? Yeah. All right. So that's the maximum portfolio loss, and the next one is to find the PDF, right? To find the, so this is the CDF. The next is to find the PDF of V is you just use the quotient rule to differentiate this, right? So it's gonna be correct me if I'm wrong. So this is the, I'm just using the quotient rule, okay? And you divide this by okay guys, so that's the PDF of the maximum portfolio loss, right? Any questions so far? You okay? Right, so the next example, I don't know if I will have time to complete it. I will just write down the example. Maybe you can do it when you have time. I mean, so this is example number 3. Suppose Okay, so here you have a random sample. Sorry, you have n investments, but the losses are independent, but they're not identical. So you have, so this is basically case number 3. Remember, we talked about 6 different cases earlier today. So this is where the losses are independent but not identically distributed, right? Because you're assuming that x1 to xn are exponential with parameter I from 1 to n. Okay, and the number of investments is fixed, so you have case 3, right? So the question is to find the CDF and the PDF of U. I will try to do it in the time I have. The CDF of U is gonna be yeah. So this is same as what I've done before, you may recall. So now in the next step I'm going to use independence. You can write this as like this, yeah. And in the next step I'm going to write this guy as 1 minus okay. Right, now this is where the things change. Now we know that x1 is an exponential random variable with parameter a1, right? A1 is the parameter for x1. So this is going to be 1 minus e of minus a1 times u, right? And this is going to be 1 minus e of minus an times u. You follow what I'm saying? Yeah, right, the ones cancel, so this becomes 1 minus e of minus a1 u up to e of minus an u, right? So this is saying that this is 1 minus e of a1 summed up to an u. All right, so that's the CDF of minimum portfolio loss. Right now, to find the PDF, I think run out of time. The PDF of U is just, you differentiate this with respect to U, so you get Alright. Okay guys, so that completes the first part of the question, which is to find the CDF and the PDF of U. You should be able to do the second part by yourself, right? That is to find the CDF and the PDF of V, which is the maximum portfolio loss. Okay, so please try to do that by yourself, and if you get stuck, let me know. Alright guys. Okay guys, I'll talk to you later. So as I said, I will return the marks and the feedback to you later today. And if you have any questions, as usual, feel free to contact me. Okay, 24/7. Okay. Thank you. Yeah. Take care.
Great to meet you. Thank you so much. Yeah. So it's a pretty easy setup basically. Like there's the Zoom, which I'll log on to now. We have USB, and then all that happens is usually I do the lecture. It's quite one way for a while, and then I have some sessions where I say any questions, and I just need you to let me know because of the fact that in the Zoom chat, and they can ask their questions into the Zoom chat. We've had a few lectures now, so they do know by now that they can do that, but I don't keep the questions on a rolling basis. I stop at specific points to see what they have to say, and they can type them. So then you can just read them out for them. It's probably easier than having yeah, I'll get the Zoom and everything set up.
So I will be co-host, right?
Yes, yeah, I'll make you co-host as soon as I've logged in.